Good morning, students. Are you all safe? Okay, continuing with our software engineering and testing paper. We have learned about the importance of SRS document, the characteristics of a good SRS document, and the organization of SRS document. So with this, we are going to the next session, software design. This is carried out immediately after forming the SRS document. SRS document contains all the important requirements specified by a customer. So after forming the SRS document, the next phase of development is the software design. So during the software design phase, the design document is produced. Okay, so after developing the SRS document, the next phase is the software design process, design phase. In that, a design document is produced, and this design document is based on the customer requirements, and it contains all those requirements specified by the customer in the SRS document. So the main objectives of the design phase is to form a design document out of the SRS document. So the basis for all those developmental phase is the SRS document itself. So the activities carried out during the design phase transform the SRS document into the design document. As we see in the figure, the SRS document is transformed to a design document through the activities carried out in the design process. The design process contains some activities. These activities transform the SRS document into a design document. So the requirements specified by the customer will be there in the SRS document. Based on the SRS document, a design document will be produced. And the activities carried out to transform this SRS document to a design document is called the design process. The design document is produced based on the customer requirements. That is, the basis for all the design document, the formation of design document is the SRS document itself. So this is what we are going to learn about in this session. The software design process. That means transformation of SRS document into a design document. Let's see deep about the software design process. Now, what may be the outcome of the design process? So, the following terms or the items are designed and documented during the design phase. First one is the different modules required. The outcome of the design process contains all these following things. Among those, the first one is the different modules required. So design process is a process that we must identify the different modules of a software. The different modules in the solution should be clearly identified. Each module, as we know, each module is a collection of functions. Independent functions are always represented as a module. So module is a collection of functions and the data shared by the functions of the module. We have to identify the functions, individual functions, and the important functions of the software, and we have to identify the data shared by the functions too. Each module each module performs some well-defined task out of the overall responsibility of the software. So it forms the important task of the software. So we have to first identify the important task of the software, and we should identify the out of the overall responsibility of the software, we should identify the important functions that is performed on the software and the data that these functions utilize should be identified. And in this step, we should identify the functions and we should name the functions too. So each module should be named according to the task it performs. For example, if you are carrying out academic automation software, the module consisting of the functions and data necessary to accomplish the task of registration of students should be named as handle student registration. So the name should be in a conventional manner. That means the name of the function should convey the meaning or the task performed by the function. So in this step, the different during the design process, the first step is to identify the important functions in the software and to identify the data shared by these functions and the naming of these functions. Okay, next one, control relationships among modules. This includes identification of the function calls among the modules. A control relationship between two modules happens only because of function calls between two modules. So the control relationships existing among various modules should be identified in the design document. Design document should specify all the function calls made by each individual functions. The function call represents the control relationship among the modules. So all the function calls in a software should be analyzed or specified in the design document. Interfaces among different modules are also identified. Interfaces happens by exchanging the data between different functions. Although we form individual functions out of the overall responsibilities of the software, there must be some function calls and there must be some data exchange between the different functions. So the interfaces between two modules identifies the exact data that is exchanged between the two modules. When one module invokes a function of the other module, there must be some sort of data exchange between the different modules or functions. So this data items, exchange of data items must be identified in the design process. And next one is the data structures of the individual modules. So each module store some data that the function of the module need to share to the to perform some desired responsibility or task. It should need to share some data. Suitable data structures for the data to be stored in a module needs to be properly designed and documented. So it is essential to form data structures for functions. These data structures should be identified. It should be properly designed and documented. Another thing is algorithms required to implement the individual modules. Each function in a module usually performs some processing activity. We know a function is identified or a function is designed to carry out some activity. It performs some task in the software. The algorithms required to perform these processing activities of various modules need to be carefully designed and documented. And some important factors or accuracy of the result, space and time complexities, these are the major factors that is to be considered while designing the algorithm for a function. So algorithm designing, it is also a job carried out in the design process, and special importance or considerations should be given to the accuracy of result, space and time complexities while designing and documenting the algorithms. These design documents are produced not in a single step. It is produced through iterations over a series of steps. The design process itself is carried out through iterations of series of steps, and the design documents once produced are reviewed by the members of the development team. This is done to ensure that the design solution conforms to the requirement specification. So we are deriving a design document out of the SRS document, so it must conform to the requirement specification. So this is reviewed by the members of the development team. Although this process is iteratively developed over a series of steps, it is not developed in a single step, the design process, but the design process is having much importance, so it is reviewed by the members of the development team to ensure that it conforms to the requirement specification. Next one, the classification of design activities. As we said, a good software design is not arrived by using a single step procedure. It is not developed in a single step. It is iterated over a series of steps, and these series of steps are called the design activities. A design document is produced by iterating a series of steps, and these series of steps are called design activities. And depending on the order in which various design activities are performed, we can classify these activities into two important stages. Preliminary design, also known as the high level design, and the detailed design. The scope of these two stages can vary depending upon the design methodologies. But for the traditional function oriented design approach, the objective of the high level design can be said as, through the high level design, a problem is decomposed into a set of modules. The control relationships among the modules are identified, and also the interfaces among various modules are identified. So the high level design or the preliminary design contains the job of decomposing the overall work into separate modules. Decomposition of the task into modules. This the overall software to be developed or decomposed into separate modules. The control relationship among the modules should be identified clearly. That means the function calls. We are decomposing the overall task into modules, and the separate modules may have relationship with the other modules that may be accomplished by establishing function calls or data exchange. So these control relationships are also identified, and also the interfaces among various modules are also identified. So we have to decompose the overall task into modules, and after decomposing the software into separate modules, we have to identify the control relationships and the interfaces among the modules. This is done on the high level design stage. Although the design stage may vary, the overall activities carried out during the high level design or the preliminary stage may vary depending upon different design methodologies. But the overall task is to identify or decompose the whole software into modules and identifying the control relationships and the interfaces among the modules. So the outcome of a high level design is called the program structure. So after performing the high level design or after the preliminary stage, we will get the program structure or the software architecture. After the high level design is complete, to decompose the problem into many small functionality independent modules that are cohesive, having low coupling among themselves, and are arranged in a hierarchy. Many different types of notations have been used to represent this high level design. A notation that is widely being used for the procedural development is a tree like diagram called the structure chart. So after the high level design or after the preliminary stage, the outcome of that process, outcome of this activity, high level design activity, can be represented with a tree like diagram called structure chart. Usually structure chart is used to represent the outcome of the high level design activity. And popularly for object oriented programming design, we may use the UML, Unified Modeling Language, is also used to represent the structure chart, that is the outcome of the high level design process. Once this high level design is complete, detailed design is undertaken. During the detailed design, each module is examined carefully to design its data structures and the algorithms. So once we have completed the preliminary stage, that is a high level design that contains decomposition of modules and establishing the control relationships and the interfaces among the modules. And these once this outcome is represented using either a structure chart or using UML, then we move on to the detailed design. In that, we need to design the data structures and the algorithms needed to specify these functions. So the implementation of these modules, for the implementation of these modules, we need to design the data structures and the algorithms. So this is done during the detailed design. So the outcome of the detailed design stage is usually documented in the form of a module specification document. And the outcome of the high level design activities are represented using either a structure chart or a UML. But for the detailed design, it includes the designing of data structures and the algorithms of the modules that is identified earlier. And the outcome of the detailed design stage is specified using a module specification document. Now, how to characterize a good software design? As we seen on the SRS document, how is that SRS document important for the designing process or the whole development of the software, and the important or the good characteristics of a good software requirement specification document. Likewise, a software design should also be good, because depending on this, based on this design document, the whole developmental activities should be carried out. So how can we characterize a good software design? The definition of a good software design can vary depending upon the application. For example, the memory size used by a program may be an important issue to characterize a good solution for embedded software development. So for embedded software development, the applications require to work on short memory sizes, limited memory sizes, or cost, space or power consumption considerations may be important in such cases. Thus, for embedded applications, one may sacrifice the design comprehensibility to achieve the code compactness. Similarly, for other applications, some applications need to be much considered about the memory size, where other may consider cost or other space criteria, something like that. So the actual characteristics may vary depending upon the application being designed. But most researchers and software engineers agree on a few considerable characteristics that a good software design application. For example, for a general applications, good software design for general applications must possess a certain group of characteristics. So among that, correctness is an important criteria for a good software design. A good design should be correct. That is, it should be correctly implemented. It should correctly implement all the functionalities of the system. So it is a general characteristics for any process, for any type of software. Correctness should be an important criteria. That means it should correctly implement all the functionalities of the system. Second one is the understandability. A good design should be easily understandable. Unless it is not understandable, the software should not, it becomes difficult to implement, and also it would be difficult to maintain the software. So it should be easily understandable. Unless a design solution is easily understandable, it would be difficult to implement and maintain it. So it should be understandable. Third one is the efficiency. A good design solution should address the resource, time, and cost optimization issues. The efficiency of a software development process depends upon these three criteria: resource, time, and cost. It is much important that we identify all these estimations. We estimate all these three factors at the beginning stage of the software development process. So a software development process or the activities are said to be efficient only if address these three considerations. It should be resource effective, time effective, and the cost effective. And the next one is the maintainability. A good design should be easy to change, because always our requirements are being changed on time. So for any software, for example, it may be a generic purpose software or a specific purpose software. The softwares need to be changed on time. No requirements remains constant for a long time. So a good design should be easy to change. This is an important requirement, since change requests usually keep coming from customer even after product release. Even after the delivery of the product, change request may be coming from the customer continuously. So it should be easily maintainable. Also understandability, and as we said earlier, understandability of a design is a major concern in the design process. For example, assume that we have arrayed at a large number of design solutions and need to choose the best one out of that. How can we choose a best design solution out of a variety of solutions? Of course, the incorrect designs have to be discarded first, and then if we are choosing from only correct design solutions, understandability of a design solution is possibly the most important issue. When considering or when choosing a correct design solution, the first and foremost thing to be considered is the understandability of the design solution. While judging the goodness of a design, understandability must be the first and foremost criteria on choosing a correct design solution. Unless a design solution is easily understandable, it could lead to an implementation having a large number of defects, and at the same time it increases the development cost also. So a good design solution should be simple and easily understandable, so that it would be easy to develop and maintain. And also a complex design may increase the life cycle cost. Unless a design is easily understandable, it would require a tremendous effort to implement, test, debug, and maintain it. So among these categories of the good software design, understandability forms an important criteria. It is a major concern. So a design solution should assign consistent and meaningful names to various design components. As we said earlier, wherever we decompose a problem into modules, it should be given a meaningful name. A design solution should assign consistent and meaningful names to various design components, and it should make use of the principles of decomposition and abstraction to simplify the design. The design should be simplified using the principles of decomposition and abstraction, and it should assign consistent and meaningful names to various design components. So, a design solution is understandable if it is modular and the modules are arranged in layers. Always a design solution will be more understandable if it is represented as various modules, and the modules should be arranged in layers. So, modularity and layered design are the two important concerns of the design solution. Modular design achieves effective decomposition of a problem. It is a basic characteristics of any good design solution. In simple words, this implies that the problem has been decomposed into a set of modules. So, this facilitates decomposition of a problem into modules, facilitates taking advantage of the divide and conquer principle. As we have learned, divide and conquer principle, it becomes more easy to identify the important functionalities of a problem, as well as it is more understandable if different modules have either no interactions or little interactions with each other, then each module can be understood separately. This reduces the complexity of the design solution. A design solution is considered to be highly modular if the different modules in the solution have high cohesion and their inter-module couplings are low. That means the modules should be independent. Also, the layered design of the modules are also important. Layered design is one in which, when the call relations among different modules are represented graphically, it would result in a tree-like diagram with clear layering. After decomposing in the overall functionalities, responsibilities of the software into modules, the module should be represented in a layered form. That means it could be represented in a tree-like diagram. In a layered design solution, the modules are arranged in a hierarchy of layers. That means a module can only invoke functions of the modules in the layer immediately below it. The higher layer module can be considered to be managers that invoke the lower layer modules to get certain tasks to be performed. So, when a failure is detected while executing a module, it is clear that the modules below it can possibly be the source of error. So, it helps in detecting the error. It simplifies the debugging process. That means we can fix the error by verifying the module that is immediately below the first module. So, this facilitates the error detection also. Next is function oriented software design. Actually, the function oriented design techniques were proposed nearly decades, around 4 decades ago. These techniques are still used by many software development organizations, and these techniques view a system as a black box that provides a set of services to the users of a software. For example, if we consider a library automation software, the services provided by the library automation software may be issuing book, searching for a book, etc. These functions of the software are identified as high level functions of the software. So, in function oriented software design, we must identify the individual or the independent functions, important functions that are performed on a software. The term top-down decomposition is often used to denote the successive decomposition of a set of high-level functions into more detailed functions. So this term, the top-down decomposition, is used to denote the decomposition or splitting up of the overall functionalities, responsibilities of the softwares into different modules or functions. After top-down decomposition has been carried out, the different identified functions are mapped to modules and a module structure is created. This module structure possesses all the characteristics of a good design. Usually the SASD technique can be used to perform the high level design of a software. We shall have an overview of the SASD methodology. As the name says, SASD methodology involves carrying out two distinct activities. First one is the structured analysis, second one the structured design. It is clear from the figure that during the structured analysis, the SRS document is transformed into a data flow diagram. So, with the structured analysis, the SRS document is transferred to a DFD, data flow diagram. And during the structured design, the DFD model, data flow diagram, is transformed to a structure chart. The structure chart always contains the modules, and the interfaces among the modules can also be represented in a tree structure. Always this tree structure is suitable for representing the structure chart. So this is the overall process carried out during this methodology. First one is the structured analysis, in which the SRS document is converted to a data flow diagram, and then during the structured design, the data flow model is transformed to a structure chart, a tree like structure. Okay, and the structured analysis activity during the structured analysis, it transforms the SRS document into a graphical model. It is called the DFD. And in analysis process, functional decomposition of the system, overall functional decomposition of the system is achieved. During the structured design, all functions identified during the structured analysis are mapped into a module structure. That means it clearly represents the control relationships among the different modules. This module structure is also called the high level design or the software architecture for the given process, and this is represented as a structure chart. The high level design stage is followed by a detailed design stage. During the detailed design stage, the algorithms and the data structures for the individual modules are designed. The purpose of the structured analysis is to capture the detailed structure of the system as represented by the user. But the purpose of the structured design is to define the structure of the solution that is suitable for implementation in some programming language. So this is the difference between analysis and the design. Structured analysis captures all the requirements of the users, while the design process, the structured design process is carried out to provide a suitable implementation, provide a design that is suitable for implementing in any software programming language. Structured analysis, this technique is based on a few underlying principles. First one is the top-down decomposition approach. Decomposition of the overall process problem is the first step. On analyzing any problem, the problem should be decomposed into modules. So top-down decomposition approach, that means the important major independent functionalities of the software should be analyzed first. The modules should be formed depending upon the important functionalities that are performed by the software. This is called the top-down decomposition approach. And next one is the application of divide and conquer principle. We could understand the problem becomes more understandable if we split up the problems into separate modules. Each high-level function is independently decomposed into detailed functions through the divide and conquer principle. And the third one is the graphical representation of the analysis. Graphical representation of the analysis result. It is represented usually using a data flow diagram. Because data flow diagram DFD representation of a problem is very easy to construct and it is very simple, but is a very powerful tool to deal with the complexity of the industry standard problems. It is DFD, data flow diagram, is a hierarchical graphical model of a system that shows the different processing activities or functions that the system performs and the data interchange among those functions. So, it is a powerful, simple representation. Using the DFD, we can form a hierarchical graphical representation of the systems where the important activities can be focused and the data exchange between the functions can also be represented using a DFD. It represents the data flow aspects, but it does not show the sequence of execution. Data flow diagram is not at all used to represent the sequence of executions, but it only represents the data flow aspects of the problem. It is not concerned with the control flow. It completely ignores the control flow, the specific algorithms used by functions, etc. It is not concerned with all those things. It represents the data interchange among the functions. It is an important technique that can be used not only to represent the result of structured analysis of a software problem, but it can be useful for several other applications, such as showing the flow of documents or items in an organization. So, DFD forms an important tool for representing the flow, representing the independent functions and the data interchange among the functions. So, we shall wind up here and we continue on the next sessions. Keep learning. Thank you.